Hello, let's look at the problem statement. Now, in the given problem statement, we are given an array of integers, nums, and we are given a target. We have to return two numbers such that the sum of the values of those at those indexes will sum up to target. Now, we can start by looking at the input. Let's just look at the first example. So let's take 2 and 7 and 11 and 15. And the target here is 9. So what we have to find out is what are the two numbers which sum to 9 and then return their indexes. One of the basic approaches for this could be the standard brute force approach. You select the first number and then you see if there is any other number that can get to this total. So we start by selecting 2 and then we check. Okay, does 7 and 2 equal 9? Yes, it does. And in that case, we're kind of okay. Now, this is the most elementary or the standard brute force solution. Choose the first element and then try to find any other element in the array that would get us to the sum of the target. So let's just write that down. Iterate through the array to find the next element that adds up to target. Now, consider a case when the input was in the opposite order. So let's say, oops, yeah, you have numbers in the opposite order where you have 15, 11, 7, and 2. And the target is 9 again. In this case, we start with 15. We check, does 11 and 15 add up to 9? No. 7, no. 2 and 15, no. Then we get rid of 15. We go with 11 again. We check 11 and 7, no. 11 and 2, no. Then we try 7. 7 and 2, we get the target. So we've got to try multiple operations. Now, as you can see, this is probably not the most efficient solution, but let's code this up first and then try to optimize this solution further. So, yeah, we're going to write the code in C. Now, the first step is to choose the first element, and as we've seen, we're going to have an outer for loop. Now, num size in the input is the size of the input array, and then we'll check with the other element. Now, because this is C, we have to malloc the result array. And the sum is target. Now, what do we do in this case? We have to give the return size equal to 2 because we're going to return an array with two elements, malloc the result array, and return it. So res0 equal to I and res1 equal to j. We can return them in any order as per the question. We'll just keep it in ij order and we'll just return res. And obviously, if we come out of the for loop, that means we haven't found anything. In that case, the return size will be 0 and we can just return uh, null. Let's try this. Our malloc is messed up. It should be the times 2 should be outside the parentheses. Yeah, we should be good here. Yes, our test cases are passing. Let's submit this. And as you can see, this works. Now we've seen that this isn't the most optimal solution. So what can we do to optimize it? Before we get to optimizing it, let's see what's making it unoptimal. In this case, we're traversing the array multiple times. We're starting with 15, trying everything after 15, then we're going to 11, then we're trying everything after 11, and so on. This is why because this is why the time complexity in this case is of O of n square. In the worst case, that is when the required target are the last two elements in the input or in the nums array, our time complexity goes up to O of n square because we are iterating over n elements n times. Now, in order to reduce time complexity from O of n square, there is there are many methods you can use. In this case, what we're going to use is we're going to increase the space complexity. Currently, the space complexity is constant. We're going to reduce the time complexity to O of n, and we're going to increase the space complexity to O of n. What we're going to do is uh, keep the data in a map, and in the map we'll keep track of the value as well as the index at which it occurs. So next time we can just search for the element that we need to get the target sum. So we'll explain how to do this. Let me just write this down. So if we have the required element in the map, and if we do return it. Now let's just take an example. Assume we have the similar input array where we have, so we traverse the similar array, we have 5, 11, 7, 2. Let's say this is the input and the target is 9 again. In this case, what we can do is we can keep all of these values in a map. So let's say we have a map, we can keep it an entry. Now you look at the indexes. The index of 5 is 0 and the index of 7 is 1. So what we can do is store 5, 0. There's nothing else. 11, 1, 7, 2. And what we'll do is every time we check, so this is what the map is going to look like. Every time we iterate, we check, okay, now what's the target? The target here is 9 minus 5. So, sorry, 9 minus 5. Is 9 minus 5 in map when you are at 5? No, you move ahead. Is 9 minus 11 in map? That's minus 2. No, you move ahead. Is 9 minus 7 in map? No, you move ahead. Is 9 minus 2 in map? In that case, we do see 7 existing, and that's where we know we have an answer. So let's try to code this out. As you can see, this time we're only iterating through the array one time. That way we can reduce the time complexity from O of n square to O of n. Keep in mind this is coming at the cost of increasing the space complexity. So let's try to code this up in C. So in C we have something called hash tables, and yeah, we are going to use hash table to code this up. Now a hash table, the UT hash table will require us to define our own structure and add our own add and check method. So we're going to define the structure. The value here is the value at the index, and this is going to be the key in the map. And then we're going to have int index, and then we have to add the UT hash function. This hashing function allows us to use the hash table. So let's just create the UT hash function and hash handle and just name it HH. You can give the variable name whatever you like. Over here, let's just create the global variable for the map. We'll call it map and we'll assign it in equal to empty. We're going to assign values to it in the add function. So let's just create the add function. Let's add index. Uh, it's always good to add comments on your function. So we're just, yeah, let's call it entry. First thing we need to do is allocate memory to this entry. So let's malloc right entry arrow value equal to value and entry arrow data equal to data. There is a macro that we can use to add the values to map. So we have the hash add int macro. In this, the first argument is the pointer to the hash table, which is map. Then we have to give the name of the key. Keep in mind the name value here signifies the key for the hash table, and then the pointer to the entry to be added. This is how you add to a hash table. And now let's just check if it contains a value. So let's write our contains value function. In Java, it's called contains key. Uh, let's just keep it contains value because our variable name is value. So let's call it value. Let's check for some value that we have. Good to write. comments for functions. Yeah, let's just call it hash table. We have the hash find int, and inside this you pass map, you pass uh, the value you're looking for and the result. And if the value is present, it will be put in the result pointer. If the value isn't present, it won't be put in the result pointer. Now let's go through our function. So we're going to iterate through the array and check if we have target minus numzi in the hash table. If we do, we return the value. Uh, if we don't, then we just add this entry to the hash table and continue. So yeah, this will be used to check if we have a value in table. Let's call it B, contains value target minus nums I. Now, if this value is not equal to null, that means this value is present in the hash table. In this case, we can malloc the result array and return it. So malloc the result array, and we need two elements. res0 equal to, we can get it from p arrow index, and yeah, res1 equal to I, and we can return. Ah, so let's just rename the variable to res. Yeah, we can just return res here. And if the value is not present, we can just add the value. We can add numzi and I. Let's do this. Oh, we have to set the return size here. Yep. And if we don't find them, set the return size to 0 and return null. Let's check this. Ooh, this should be, yeah, this should be a pointer to val. So sorry. So yeah, ampersand val, that should resolve this. Okay, that's interesting. Um, yeah, so let's just look at the values in the hash table. This is interesting, shouldn't happen. So two of the test cases are working and one test case is failing. So yeah, just going to print the hash table to see what's going wrong here. Um, yeah, simple for loop should be sufficient. Res not equal to null. We can use res equal to res arrow h dot next. RHS would return void, so yeah, we have to cast it. Yes, RHS dot next. Yeah, this looks good. And just print the index and value. Print the value and index. So yeah, that's some spacing there. IDX. You may want to put it a new line. Don't want everything clustered in one line. And yeah, let's see what's going on. Let's look at. It's actually taking values from previous thing. Okay, so yeah, we can avoid this by just setting map equal to null after every iteration. Yeah, yeah, this should work. Yeah, let's submit this. Yeah, we can actually get rid of the function here as well. It should be a bit faster. Yeah. Yeah, so this is how you can solve this problem using C. Thank you so much for your time. Have a lovely day.